the definition of them, okay? You know that the Fourier series have three forms, right? Is in the EMAT, you know that it have only one form. It have the three-cone form, okay? Is a three-cone can represent only for the real, okay? If xt is a real, you can, okay, you can compute them in the three-cone, okay? In the Fourier series in the three-cone form, okay? The three-cone is maybe convert them to be about the complex three-cone form. Okay, is, wait a minute. Okay, it's a three-cone and a combined three-cone form. Yeah, this, right. Okay, for the summary from the previous lectures. Okay, can you see in the slide? Hello?
Yes,ค่ะอาจารย์
Okay, เห็นนะ Okay.
Yes, sir.
It's okay in the pure three-cone form, trigonometry forms. Okay, this form I think almost all of you already familiar about that because almost all EE maths, okay, textbook or maybe the course outlines, okay, will be figures teach you xt can be expressed in the term of the Fourier series that comprise of the cos and the sine function. This form we call them the three-cone form. Okay, the three-cone form sometimes we can convert them to be a complex combined three-cone form. The same, both of them is the same. Okay, but two of them have a limit of usings. Okay, this thing can apply only on real signal, only real signal. If xt is a real, I forgot to turn off. Okay. I forgot to turn off the mobile phone. Okay, we turn off them first. Okay. Sorry. Okay. 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 The Fourier series. Okay. Both of this form can apply only on the real signal. It cannot apply on the complex signal, okay? Even though in the real case, in the natural case, when you measure the signal from the nature, okay? For example, you record the signal, maybe my voice, okay? Or the transmission signal in the antennas, okay? Or maybe you capture the image, okay? From the real data, okay? Almost all is a real signal, yes. Therefore, it means almost all signal, you can use this Fourier series to represent them, okay, if that signal is a periodic, okay. But in some case, okay, but this case is only the special one, okay, it's only the special case, okay. In fact, the Fourier series, okay, the Fourier series will be represent for complex signal, okay. For the complex signal, xt is a complex signal. Okay, you must use this form, the complex exponential form. Therefore, the complex exponential form seems the superset of all. Okay, the complex exponential form, if is can apply only on the real or in the complex. Okay, if xt is only the real, okay, you can use, okay, the tricone or combined tricone. But if it's complex, you cannot use tricone or combined tricone to represent them. Remember that. And in this course, okay, we will expand your idea. Okay, in EMAT you have when you found the periodic signal, you use the Fourier series form, three-cone form to model it, okay, to represent them. But in this course, when you found the periodic signal, whether it's real or it's complex, we figure model them by complex exponential form. Yeah, the general form. This form we maybe call them the general form. Okay, this form you can see that it means superset. Okay, it's broader than the thing that you study in EMAT. Okay, now we will go back. Okay, I will teach you about this. Okay, three formula you must remember, and the way to find AK is by this formula. Okay, you know that. Okay, K1, K2, A1, A1, AK, and so on. Okay, now next one. Okay. Okay. The Fourier series of this. Yes, correctly. Okay. Okay, the next topic we will represent about the Fourier representation for the continuous time periodic signal. Okay, is okay the fourth topic. Okay, the fourth topic is about the convergence of the Fourier series. What about the convergence of the Fourier series? The convergence of the Fourier series is mean, okay, what about the situation that xt can be used to compute AK, or it mean AK is not infinity. Okay, how do you know? Okay, in this case, you know that, okay, we assume any periodic signal you can express in here. No, only some signal, some xt, even though it's periodic. Okay, but you cannot find AK. Sometimes, okay, xt, some function, is don't have AK. When you try to determine AK from this formula, the AK equal to infinity. Okay, the AK equal to infinity. Now we have the questions. How do we know which function, which xt have AK, which xt cannot find AK? Okay, if the function is very complicated, okay, you cannot waiting until you integrate by AK. If you use AK directly, okay, determine AK, you integrate them maybe 20 pairs and give you infinity. It's waste our time, okay, it's not good. Therefore, in the mathematical analysis, okay, we have some ones, okay, the derivative will be proposed the condition to make sure that the AK will be converse or AK is exists, okay. In general, the Fourier series can be used to represent the broad class of the periodic signal, but the Fourier series cannot use to represent some periodic, okay, some periodic. Therefore, this formula is not true. It cannot apply in all cases. It can apply on only some case, okay. The case that you can see that the signal or xt is a signal, we see them to be the signal. The signal that's the stable signal. If xt is unstable signal, you cannot find AK, okay. From the Fourier series definition, any periodic signal can be expressed as an infinite summation of the harmonically related complex exponential. Therefore, the finite summation of the harmonically related complex exponential can be used to approximately any periodic signal. Okay, it means from this formula, you can see that when you write the series solution, okay, when after you get AK, okay, this formula will be present or will be get AK perfectly if you use infinite series. Okay, K will be starting from infinity to infinity. It means this term must be infinite series. Okay, but if you use finite, for example, if you use only 10 term or 20 term or 100 term, okay, you know that the signal xn that you create or you resolve will be close to xt, but it's not identical. Okay, okay. Now let's xn to be here. Okay, xn is the signal that you construct by the finite series. Xt is original one. You know that it has some difference between them. Okay, when you subtract between xn and xt original signal, okay, you get the error. So get the error. Okay, and here you can express xn will be in the Fourier series form. Okay, now we define xn denote to be approximation error by this equation, and the energies of the error functions over one period can be determined by you integrate them one period. Take square and integrate one period. Okay. Okay. From the above equation, if n is increased, okay, you know that if the series of them, okay, if you use 10, okay, if you use only 10 series, okay, it may be poorer than you use 20. 20 series will be close to xn original one. Okay, 10 is maybe far away. Okay, therefore, if n is increased, then the error is decreased. Therefore, if n is equal to infinity, if n equal to infinity, this term is become xn and the error will become 0. Okay, for some signal, the Fourier series coefficient AK may be infinity or the Fourier series may not be converged. Okay, if the signal xt have a finite energies over a single period or satisfy the derivative condition, then the Fourier series is exists. Okay, now one of the mathematicians is proposed the idea to prove that which signal, okay, if the signal follow the derivative condition, the three conditions of the derivative, it guarantees that, okay, that signal have AK. You can compute AK, and the AK is not infinity. Okay, what about the condition that the derivative proposed? The derivative is proposed. The first condition is that over any period, xt must be absolutely integrable. It means, okay, you set absolute of them and you integrate them in one period, okay, and it must be less than infinity. I used to state several times, okay, the physical meaning of the differentiation and the integration. What about that? Okay, if you differentiation of that function of the cloud, it gives you the slope of that cloud. But if you integrate the cloud, it gives you the area under this cloud instead. In this case, okay, you integrate them, okay, you integrate them under this area, one period, okay. In this case, checking first, the signal is periodic or not? Yes, it's periodic because the pattern of them will be repeat every 1 second, okay, every 1 second, okay. Now in this case, xt equal to 1 divided by t. Now checking that it's possible to integrate and determine them in one period or not, okay. You integrate them, okay, give you 1 divided by, okay, 1 divided by t, integrate them, give you 1 t. When you substitute 0 and 1 in one period, give you minus infinity, okay. Give you minus infinity, what happened? It means it's not good, right? Therefore, the area under this cloud is unbound, okay. Therefore, in this case, this cloud is violated, okay, or broken the directive's first condition, okay. Therefore, it's not guaranteed that the signal have Fourier series or not, okay. Remember that if the signal satisfies three conditions of the derivative, it guarantees that it have AK. But even though the signal broken some or all, we don't know it have AK or not, okay. It may have AK or it may don't have AK, okay. Remember that, okay. Now in any finite, the second condition is that in any finite interval of time, xt is about variation, that is, there are no more than a finite number of the maximum and the minimum during any single period of that signal, okay. It means the number of the maximum point and the minimum point in one period must finite. It may be have a 10 point, 100 point, 1,000 point, million point. But if you is countable, it means it's finite. Okay. Now in this case, the size, this is a function, is a size 2 pi divided by t in one period. Okay. You can see that the signal is a periodic. Okay. But when the value of them is close to 0, okay, the periodic of them is more denser. Therefore, it have the a maximums, okay, infinite point in here. You can see that in this case, the signal is violated the second derivative condition, okay, because the number of the infinite point, the number of the maximum point is infinite, okay, and the number of the minimum is infinite too, okay. But when you checking them again, okay, this signal is satisfied the derivative first condition or not, you checking that, okay, this signal is only, okay, the y of them is 1, the height of them is between -1 and 1, right? Okay, you take absolute of psi, okay, you bring some negative signal to be positive 1, okay. Therefore, the area of this signal never greater than 1 by 1, right? 1 by 1. Okay. Sorry, I have a I have a cool a little bit, okay. Therefore, I must bring speaker list unless I will be cautious, okay. Okay. However, okay, the signal satisfy the first derivative condition. You can see that even though it satisfies the derivative first condition, but it's violate the second condition. Okay. You can see that when you integrate them in one period, okay, you see that the area of this cloud, the area under this cloud is between 1 and 1. The y of them is 1, the height of them is 1. Therefore, the area never exceeds than 1. Okay. Now for the last one, the derivative condition 3. In any finite interval of time, there are only a finite number of discontinuity. Furthermore, each of these continuity is finite. Okay. in this case, okay, it said that the signal in one period, okay, it can have a discontinuity point, such as unit step, okay, we have a single, okay, discontinuity point, okay, but it can have a finite discontinuity, okay, not infinite, okay. In this case, the signal, if it's okay, if the increase by half, okay, it will be changed the value by half. Remaining by half, you change the value by half, and by half, and by half again. You can see that in this case, okay, the signal will be have infinite discontinuity. Therefore, the signal will be whereas the third condition. Okay, for the first condition, you can see that the area of this signal, the y of them is a, the height of them is 1, right? Therefore, the area of this cloud never exceeds than a. Therefore, you can state that, okay, this signal is, okay, the area of them is finite, okay, is stable. It means the signal is have satisfied the derivative first condition. For the second condition, check that, okay, the number of the maximum is have only 1 point, is here, is equal to 1, right? It's fine, 1 point, okay. The minimum is 0, yes. Therefore, however, the signal satisfies the second derivative condition. The maximum is equal to 1 and the minimum is equal to 0 clearly, okay. But it's violate the third condition. Okay, the next one, okay, in order to demonstrate, that, okay, we have 3 derivative conditions to test the signal, okay. This, okay, the next will be demonstrated between the original signal and the approximate signal, okay. The difference between the original signal and the approximate signal when you increase the number of the series, okay. If you use the series to be infinite, okay, yes, xn will be identical to original signal. But if xn, okay, if you use only 1 or 2 or 3 series, is far away from, okay, far different from xt directly, okay. Now in this case, okay, we will show you the situation, and these situations, one maybe 100 years before, used to exist in the scientific phenomena, okay. In the 1898, Albert Michelson's American physicians, okay, construct a harmonics analyzer. When he synthesized a square wave, the synthesis square wave have a ripple at the edge of the discontinuity. Okay, 1 year after that, okay, it give the data to the Joseph Gibbs, the mathematical physicians, okay, to analyze them. Okay, the Gibbs will be investigates the ripple at the edge of the discontinuity. This thing we call the Gibbs phenomenon. For the discontinuity, the ripple of the partial sum of the Fourier series exhibits a maximum value of the 9% of the highest of the discontinuity for all n. And this phenomena imply that the summation of the Fourier series approximation xn for the discontinuous signal xt usually will exhibit the high frequency ripple and overshoot xt near the discontinuity. Okay, what about this? Okay, you can see that, okay, if we use, okay, in this case, the originals, the xn is the rectangle waveform, okay, the rectangle waveform, okay. This is also in the cloud we use, okay, I use the MATLAB to simulate them, okay. This cloud we use, okay, the Fourier series, okay, when we use k equal to 1, okay, is k equal to 1, okay, we use the series, but we use only one series. This we use 3 series together, okay, A1, A2, A3, okay, combined together, okay. You can see that what happened. If you use, okay, ck equal to 1, okay, it's far away, okay, far different from the rectangle. But if you use ck when k equal to 3, 1, 2, 3 combined together, it close similarly to the rectangle, but it have the ripple in here. You can see that, and it's still a little bit far away from the rectangle. Now, if we use it small, okay, if we use k equal to 5, okay, it still have the ripple in here, but the shape of them is close similarly to the rectangle. If we use 7, okay, it's here, the ripple is still 9% in here, never it decrease, okay. We use, okay, if we use, okay, k up to 19, okay, give you here, and even though you use k up to about 200. Okay, it still have the ripple in here, but it don't show you in the graph because it's very small one. Okay, here in this case we can summarize that this situation we call the gift phenomenon. In the real case, okay, this thing can exist in every instrument, every signal generators. Okay, the function generator in the RAP, it cannot generate the infinite series. Therefore, it can generate a very high, maybe n equal to thousands or the million, okay? But it's finite. If it's finite, it still have the ripple in the discontinuous point, okay? And the discontinuous point, you can see that if it have the ripple in here, it always have the 9% overshoot, okay? It always have the 9% overshoot in this, okay? In the discontinuous, okay, point. Always have, except you use infinite series. But in the real world, do you think the human can generate the infinite series? No. Okay. Therefore, in the mathematical analysis, okay, you can see that the mathematics can generate anything to infinite. Okay. Therefore, the mathematics is seem to be go maybe to the other universe already. But the physics work. The physics work from my point of view is only in the world, okay, in very close one, okay. A lot of the phenomena we cannot measure them because, okay, we cannot know them clearly, okay, the same as this situation. Okay, now, okay, in order to make you understand, now for this lecture I give you two things. One, okay, the Dirichlet condition. We have three conditions to check that the signal is stable or not. Okay, the Dirichlet condition one, okay, for absolutely integrable. The second one, okay, minimum and the maximum point. Okay, the last one is, okay, is have the finite discontinuity point. Okay, and the next is the gift phenomenon. The difference between, okay, the Fourier series for the finite term, okay, and the original signal. Okay, the original signal you can see them to be the Fourier series infinite term. Okay? Now in this case, we give you a little bit more exercise, okay? This exercise already in the end of your book, okay? You can do by yourself, but, okay, this thing will give you the solution, okay? Instead, we don't have the class anymore, therefore I cannot force you to sit and do it. I think it's worth the time, okay? Therefore, I will provide you solutions, okay? And you will do it by yourself, okay? Now, this function is more difficult than the previous because the function is a ramp function, okay? Using the Fourier series definition equation, determine the Fourier series of the signal shown in this figure, okay? Checking first, the signal is can find the Fourier series or not, it must periodic. It repeat or not, the pattern of them is repeat, and the period of them is 2, right? Is 2, you can see that. Now, if you integrate here, okay, the function is t, right? The slope of this function is t, okay? The Fourier series concept, the difficulty is how to model xt, okay? Okay, okay, in this case, xt, you can model them by, okay, writing the graph. This piece of this graph, I think, if you know this graph, you can know how to find the function of them, okay? How to find the function of them, you can see, yeah, it's very easy, ET, okay? I will show you a little bit one, wait a minute, okay, whiteboard. Okay. Can you see my whiteboard? Hello?
Yes, Ajahn.
Yes, Ajahn.
Can you see whiteboard, right?
Yes.
Okay. Okay. Okay, this graph is about here, right? I write by my Microsoft mouse. It's not, okay. Okay, it's maybe not perfectly. Okay, you can see that this graph, okay, the key of this graph, right? You cut this graph in this piece, right? Okay. Okay, when you write them, okay, in this case, you write in the x and t, okay, I understand that you may be not familiar about them, okay? You may be seen them to be y and x, okay? The same as you study in, maybe in the calculus 1, right? This graph is equal to y equal to, do you remember? Ax plus b, right? Plus b, okay? The formulation, okay? The slope of this graph, a is the slope of this graph, right? The slope of this graph, you can determine them by, okay? A equal to delta y, right? dy by delta x, okay? Delta y is here, right? Delta y, delta x is here. In this case, it's equal to 1, right? Delta x equal to 1. Okay, the slope of them equal to 1. Okay, 1. Okay. Therefore, this graph can simplify to be here, right? B is a constant value to cut the axis, right? You can substitute any point in them. In this case, if you substitute this point, okay, this point is 0 and 0, right? 0 and 0. Okay, substitute them in here. Therefore, in this case, B equal to
0.
yes, B equal to 0. Therefore, you can summarize that y equal to x easily. Okay, or you change them to be the graph that we frequently use in the signal and system and the others. Okay, will become x equal to t. Clear? Can you see this slide? Okay, you can see that the difficulty of the Fourier series and the Fourier transform is how to write the graph in the mathematics form. And you substitute them, you integrate them. The way to integrate them, okay, is maybe require the bypass skill or so on. Okay. Now, okay. Clear? Okay. Oh, sorry. We came back in here. I think everyone can see the whiteboard, right? Know that, okay, y, okay, y, okay, this step is go very fast. Xt equal to t, you know where it came from, okay? After you know that, okay, you know that's, okay, the 1 period equal to 2, right? T naught equal to 2, you substitute them in here, therefore omega equal to 2 pi divided by T naught equal to 2 pi divided by 2, reduced to be pi, and this means omega naught equal to pi, you substitute them in the Fourier series coefficient equation, okay? Now you integrate them. Integrate, okay, from -1 to 1. You integrate only 1 period. Yes, you integrate only 1 period. Okay. And in this case, you integrate, even though this term is very complex one, you integrate T, E, T, right? E, EAT. TEAT is mean it requires the bypass skill. Okay. It requires the bypass skill. Okay. The way to find the bypass, okay, I think you can integrate by your skill. Okay. Therefore, the bypass, the other techniques in the integration that you study in the calculus 1, we will use now. Okay. Okay. This Fourier series concept is only here. Cut the signal in 1 period, formulate the equation, okay, push them into the xn, okay, 1 period. After you formulate them completely, the way of the integration, the way to find the result is beyond of our scope, okay? It depends on your calculus skill, okay? You integrate them and substitute the rank of them from -1 to 1, okay? -1 to 1, okay? Now, you reorganize the form, okay? You reorganize the form, grouping them, okay? Give you here. Okay, and the techniques for the Fourier series that I will tell you. Whenever you find the term that have E, J minus J theta, okay, and E plus J theta together, okay, each term that have the same coefficient together. You know that this term, you can combine them, change them to be trigon, okay, remember that we try to change them to be trigons, okay, as much as possible, okay, if it can change, try to change them, because the trigon is seem easier than the complex exponential, okay, yeah, you know that E minus J theta plus EJ plus theta divided by 2 give you cos theta, okay, But if it's subtract, you must minus divide by 2j. It becomes sine instead. Okay. The first term is a cos. The second term is a sine. Okay. Okay. But this case will be here. Okay. Now the next one come here. The next one is here. Now the same, but this thing is different from the previous. Okay. This thing in this case. Okay. The slope of them is not 1, right? Delta y and delta x. Delta y equal to 2, delta x equal to 1. Therefore, the slope of this graph equal to 2t, okay? And even though it's close similarly to the previous, but the way of the integration is maybe starting from -1 to 1, but you separate them in two zones, okay? The first zone will be 0, okay? 0. The second is 2t, okay? TEAT again. You integrate TEAT, we will give you the bypass skill. Okay, you must use the bypass skill to integrate them again. Okay, integrate the bypass, and in this case, you substitute the range between 0 and 1. 0 and 1. Okay, 0 and 1. Okay, give you here. Okay, 0 and 1, and this is a final form of them. Okay, the next step, okay, if the function is not easy, okay, it's here, okay. This case, okay, give you, it's already this case is very easy for you because this case, the function already give you in the mathematics function, right? Therefore, you can push them in the equation directly. The first one is t, the second one is 2 minus t, okay? The first one integrate between 0 and 1, the second one integrate between 1 and 2. Therefore, in this case, okay, the period of them equal to 2, between 0 and 2, right? The period of them is 2, okay? Substitute 2 in the t naught. Okay, you will get omega naught equal to pi. Okay, and you can simplify omega naught equal to pi in here. Okay, now you integrate, okay, TEAT, but in this case, you can see that this thing is 2 minus t. You can distribute, okay, EAT to be here in two terms, okay, and you integrate them in here, right? Distribute them, okay. Okay, 2 is here, okay, this term, okay. And this term is t minus t is here. Okay, this first term and the last term require the bypass skill to integration. Okay, integrate u dt equal to uv minus u dv is here. Okay, integrate them. Okay, bypass and substitute the rank of them between 0 and 1. For here it's very easy. This term is integrate only EAT. Give you EAT divided by A. Okay. And the pink one is required bypass skill again. I will be, okay, brings the computation shortly, okay, to reduce the time. Okay, I think the way to integrate them, I think you already know. How to track that, how to integrate them, okay? Remember that you cannot blame that you forgot how to integrate, okay? The integration and the differentiation is the heart of the mathematics in engineering, okay? If you forgot that, nothing lost, okay? You have nothing left in here. Okay, you must integrate them. Okay, in this class, okay. For example, if these subjects, okay, if this course have, okay, this problem, sorry, this problem is 10 marks. Okay, if you can formulate the Fourier series mathematics equation correctly, okay, you get 2 marks after you formulate this equation. 20% give it to you, and the rest is depend on the integration. Okay, if you can integrate them correctly, okay, you get another, okay, 6 marks, okay, until you get the final form. Okay, yeah, you substitute the rank of them from 0 to 1. Okay, 0 to 1, okay, and 0 to 1 for the first term, okay, 1 to 2 to the second term, 1 to 2. You see that 1 to 2, 1 to 2 to the third term, 1 to 2. Okay, and if it's 0, you can see that anything multiply 0 give you 0. Anything power 0 give you 1. Okay, therefore this term will be simplified very easy. Okay. Okay, and after you reorganize the equation, you can see that some term can cancel each other term. This term and this term is identical, but the sign of them is different. you can merge them and so on. You can see that all 5 terms, it cancel each other, okay? It can reduce. Therefore, the remaining is here, only here, okay? You can keep here, you can simplify to be here, okay? Next step, okay? In this case, right, I told you, when you see that, okay, when you see this, okay, you can see that, okay, the term is, okay, you can grouping them to be square, and in this case, it's again, E plus J theta minus E J theta again. If it minus, it means you try to organize them in the term of sine, okay, in the term of sine again, okay, sine square, okay, sine square. And the sine square, you know that, okay, from the trigon, you can convert them to be cos 2t, okay, cos 2, okay, cos 2 times, okay, sine square theta equal to 1 minus, okay, cos theta, cos 2 theta, sorry, cos 2 theta, okay. Now the next one, okay, the next example, okay, use the Fourier series definition equation to determine the Fourier series of this graph. Now this graph is a little bit more complicated, okay, 2 and 2, 2 and 1, okay. In this case, wait a minute, okay, okay, we can you see my whiteboard?
Yes, Ajahn.
Okay, I will show you here, right? 2 and 2. Okay, you can see that in this case, okay, the graph, when you model them, okay, you separate them into pieces, right? The first piece is here, right? It's here. Okay.
Ajahn, I think you need to move it a bit, right?
So?
I think you need to scroll it a bit, right? Because it's not showing the full graph.
Huh? You can see the whole graph?
No, I cannot, Ajahn. It's outside the screen, I think.
Oh, really? Wait a minute, wait a minute. Here? You can see only here, right? Therefore, wait a minute. Oh, sorry. We how to erase that. This graph. You see only in the center. And to write this. Eraser. Sorry. Okay. Okay. Sorry. Can you see this graph?
Yes, Ajahn.
Now you can see, right? Okay.
Yes.
Okay. 2 and 2. Right. Okay. This one. Okay. Okay. You can see that in this case, you must model 2 graph, right? The first piece is here. Okay. The first piece. Okay. Y equal to ax plus b. Okay. Ax plus b. Okay. Or if you write them in the, okay, in this graph, in x and t, right? You may be right to be x at plus b. Okay. Okay. Now the slope of them equal to, okay, delta y divided by delta x, right? Okay, equal to 2. Okay. This thing equal to 2. Okay. The slope of them equal to 2 by 2 equal to 1, right? 2 by 2. Okay, give you x equal to t plus b. Okay, now you select only one point. Okay, this point, for example, substitute them. Okay, this point, the coordinate of them. Okay, x equal to 2, y equal to 0, right? Substitute them in this equation, and you can get. Okay, and you can get b. Okay, okay, x equal to 2. Okay, t equal to or y equal to 0, right? 0. B. Therefore, in this case, b equal to 2. Okay, you will get that. Okay, this equation equal to t plus 2, right? T plus 2. Clear? Now for the second class, the second class is here. Okay, the same. X equal to a t plus b, right? The slope of them, be careful. Okay, the slope of them is negative, right? Delta y divided by delta x. Okay, but it's negative. Okay, it's negative. If you, yeah, delta y equal to 2, right? Delta x equal to 1, but it's negative. It will be minus 2. Okay, the slope is down, it's negative. Okay, this equation will become 2t plus b. Okay, now you pick one point of them. In this case, you can pick any point. If we pick here, this point, okay. Oh, sorry, it's I wrong a little bit one here. It's not minus, sorry. It's not minus here, okay. Wait a minute. To be 2t, yes, x equal x and y. Sorry. This thing a little bit error is here. Sorry. Okay. This point x equal to this x equal to 2. Yes. Okay. I forgot that it's confused about x and y. There it's x again. Okay. In fact, okay, it will be t, right? This thing is t. Okay, and this thing is x. Okay, substitute them. Sorry that. Okay, this 0, right? Okay, x equal to 0. Okay, oh sorry. Okay, this 0 equal to, okay, t equal to minus 2. Okay, plus b. Okay, therefore b equal to 2. Fortunately, that is lucky, that is correct one. Okay, now the final answer is here. We become x equal to t plus 2. Okay, the first equation. Okay, now for the next one, this point is, okay, is t equal to 1, right? Okay, 1 and x equal to 0. Okay, substitute them in this equation. Okay, here 0 equal to minus 2 and sorry, okay, t equal to 1 is here. Okay, s is 0 is here. Okay, plus b. Okay, therefore in this case b equal to 2. Okay, substitute them. Okay, substitute them in this equation again. You get, okay, x equal to minus 2 t plus 2. Okay. Can you follow that? I try to solve the step by step. I think this thing is maybe grade 7, right? Okay, the mathematics for the grade 7 skill, therefore I don't solve it. Okay, substitute them for a long time. And you can see that my handwriting in the whiteboard is very poor because I use mouse, okay, to write them, not the pad. okay, but I try to keep expanded, okay, because if I don't write them in here, you cannot fully understand where it came from, okay. The first part equal to x equal to t plus 2, right? The second part equal to minus 2t plus 2, okay. Now we can come back to the slide again, okay. Yeah, can you see the slide? Hello, can you see the slide?
Yes,
Okay.
yes.
Okay. Now, after I explain them in the detail, you know where it came from. Okay. Here, the period of them in this case, one period equal to 3, right? From here to here. Okay. Equal to 3. Okay. And this club model equal to t plus 2. You know where it came from. Okay. And this part is equal to minus 2t plus 2. You know where it came from. Even though when I substitute them, it's only in a single step equation, but the way to compute them, I already show you, right? Okay, if you can compute faster than this, it's a good, okay, but you require your computation skill, okay. Next one, okay, t naught equal to 3. T naught equal to 3, substitute them in here, therefore in this case, omega equal to 2 pi divided by 3, or yes, yeah, 2 pi by 3, okay. When you substitute them in here, you can see that you must distribute them, okay, into 4 terms, right? T separate between t and plus 2, t and plus 2, okay. The rank of the integration will be the same rank between minus 2 and 2, minus 2 and 0, sorry, minus 2 and 0. Okay, the second group is here, minus 2t and plus 2, minus 2t and plus 2. Okay, the integration rank start from 0 to 1, 0 to 1, 0 to 1. Okay, the first term and the third term is the gain is, okay, we move minus 2 in front of that, okay, to have only TEAT. Okay, TEAT. TEAT is the first term and the last term is required by Pascal. Okay, for the second term and the fourth term is easy. Integrate E is integrate TEAT is very easy. Okay, now for the by Pascal, okay, the first term is very big one, is here. The third term is very big one, okay. The second term is very easy, okay. The fourth term is very easy. The rank of them from minus 2 to 0, minus 2 to 0, 0 to 1, 0 to 1. Okay, okay, substitute 0 is given you to here, okay, 0. Anything power 0, multiply 0, give you 0. Anything power 0, give you 1. Okay, the green is mean it's not 0. The green is equal to 1. Okay, the green is equal to 1. Okay, okay, equal to 1. The green is equal to 1. Okay, and this term is 0. Therefore, it's have only minus 1 left. Okay, and this term is 1, 1, 1. Okay, this term is 1. Okay, now we can check that. Okay, this term and this term is cancel each other, right? This only, okay, 2 by 3 minus 2 by 3 cancel each other. Okay, you can simplify this form. Okay, distribute them. Okay, and it cancel each other more. Okay. Okay, we try to group them, this term and this term, right? You can see that it's the same form, okay, but the coefficient is different. Okay, the first is 1 by minus 1 by 3, this minus 2 by 3 combined together equal to minus 1. Okay, the second form is here, okay, minus 2 by 3, minus 2 by 3, okay, the same is equal to minus 4 by 3. Okay, okay, you grouping them. After that, you try to recognize them. Okay. Okay, from the above equation, okay, you can express them in the okay, grouping them again in the sine and in the cos as much as possible. Okay, don't worry about that. If you may have a question, okay, you can integrate them, but you can find only this step. Okay, you cannot find in the final rank. Okay, if you can find until this step, you already get the 90%. Okay, or the 95%. Okay, you cannot reach the last one. Okay, you lost only 1%. Maybe only 1 or 0.5%. Okay. Okay. Sorry, you lost only maybe 5% or 10% left. Okay, sorry. Okay, it means if this point of this, okay, if the mark of this problem is 10, okay, you integrate until you reach this process, you get only 9%. You get about 9% or 9.5 approximately. Okay, If you can reduce until the last one, you get another one. Okay, you get completely. Okay, next one. Okay, use the Fourier series definition equation to determine the Fourier series of this form. Okay, this term is a little bit more complicated again. Okay, it's in the sine wave, right? It's the sine wave, but it's only, okay, 1/4 circle is there. Okay, use the Fourier series definition equation, determine the Fourier series of this. Okay, checking first, the signal is periodic or not? Yes, it's periodic. Okay, the period of them is 4. Okay, from the Fourier series definition, okay, you can substitute that. Okay, the period of them is a 4. Therefore, T naught equal to 4. Okay, substitute for T naught equal to 4 in here. You can conclude that omega naught equal to pi 2 pi divided by 4 or pi divided by 2. Okay, okay, in this case, you substitute the rank of the integrations from -2 to 2. Okay, the first one and the last one equal to 0. Okay, only the middle one. The middle one is a cos, but remember that in this case, it's told you is a sinusoidal, but it's not the sine wave. Okay, it's not sine t. Checking that is a sinusoidal, it can be sine or it can be cos. Okay, the peak of this cloud will be reached the maximum at the 0. Therefore, the cloud will be cos. Okay, and the peak of them is 2. It's not 1. Therefore, you magnify. Okay, use the the amplitude scaling by 2 of that signal. Okay, 2, and the cloud will be, okay, the periodics, okay, is 2 pi. 2 divided by, okay, pi divided by 2 t, okay, omega sine omega t, okay, and is here, omega is about here, and after you get here, e t cos t, you can see that. Remember that integrate cos e t cos t, okay, is required by Pascal again. Okay, you may be use the table or you may be use, okay, the way to integrate them and substitute them. Okay, use the table is here. Integrate EAT cos BT dt is give you here. Okay, therefore from the above equation, okay, you can guess here. Okay, you can guess here. In this case, A equal to minus JK pi divided by 2. Okay, it's here. Minus JK pi divided by 2. Okay, A is here, distribute in this. Okay, and B is, okay, B equal to pi divided by 2, 0.5 pi is distributed here. After you distribute them, okay, you can substitute them. Sine 0 give you 0. Okay, sine 0 give you 0. Cos, okay, cos minus 0.5 pi or 0.5 pi equal to 0. Okay, we can cancel this. Okay, this term and this term is 0. After that, okay, anything powers multiply 0 give you 0. Okay, cos 0 give you 0 again. Oh, sorry, cos 0 give you 1. Sorry, cos 0 give you 1. Sorry. Okay, the next step is here. Okay, distribute them, grouping them, give you here and here. You will see that this term we have pi 0.5 pi divided by 2 as the common term. Okay, you can bring them out. Okay, the remaining is here. You can reduce here. Okay, pi divided by 2, pi divided by 2. So, okay, you can cancel each other, and then after you simplify, bring you here. Okay. The next one maybe give you, okay, in this case is just argue in the different point of view. Okay, a continuous time periodic signal xt is a real value and have the fundamental period is x. Okay, the non-zero Fourier series coefficient xt is specified by a1, okay, and a minus 1 equal to j, okay, a5 equal to 2, okay, express xt in the trigon form. Okay, here you can see that in the Fourier series distribution you can get here, okay, the formulation of xt is starting from k equal to minus infinity to infinity, ak is here. In this case, you know that, okay, the period of them is x, t naught equal to x. Therefore, you substitute them, omega naught equal to 2 pi divided by x or pi divided by 4. Okay. Okay. And you write the distributions from all, okay. In this case, it shows you that it's 0 all, except only two coefficients, the coefficient at 1 and minus 1, 5 and minus 5. Okay. Minus 5, minus 1, 0, 1, and 5. Okay. Two of them, okay. The coefficient of, okay, at the 5 equal to 2. At the 5 equal to 2. At minus 5 equal to 2. Okay. 5 and minus 5 equal to 2. Okay. And the coefficient as 1 and minus 1 equal to here. Okay. 1 and minus 1 equal to j and minus j. Okay. And it's conjugate. Okay. Therefore, minus 1 equal to minus j. Okay, it's conjugate. Next step, okay, you combine that, rest is a 0. Therefore, the remainder coefficient will go to here. Therefore, xt, you can distribute them and give you here. Okay. The questions ask you to determine them in the three-cone form. Okay. This thing is not a three-cone form. This thing is a complex exponential form, right? You grouping them. Okay. This term, okay, this term and this term have the e j theta, e minus j theta. Okay. And this term, okay, you can see that it will be e j theta and e minus j theta. Okay. You can grouping them, and after that you can merging them. After you merging them, you can see that the first term, okay, this term is e plus j theta, e minus j theta. Okay. Adding, it will become psi. This term will be minus, therefore it will become, oh sorry, this term is become cos theta. This term is become sin theta. Okay. If it's sin theta, it's must divide by 2j. But this term is cos theta divided by only 2. Okay. You organize them, give you here. J square give you minus 1. Okay. Therefore, this form will be distributed in the sine and the cos is already expressed in the three-cone form. Okay, these equations, okay, the example is the same as the previous example, but it's a little bit more complicated because it have more non-zero coefficient. Okay, okay, in this case, a0 equal to 2, a2 and a minus 2 is a complex conjugate equal to exponential j pi divided by 6, okay, and a4 equal to here. Distribute them the same as the previous from the Fourier series definition. The Fourier series ak of the continuous time periodic series is here, and the period of them in this case equal to 5. T naught equal to 5, omega naught equal to 2 pi divided by 5. 2 pi divided by 5. Okay, substitute them in the omega naught in here. You expand the series, okay, from, okay, minus 4, minus 3, you can script them because it's a 0. Only ak, a minus 4 is non-zero, a minus 2 non-zero, and a0, a plus 2, and a4. Okay, a plus 4 is non-zero. Okay, only 5 terms that the Fourier series is not 0. Okay, substitute them in the next step. Okay, okay, for a minus 4 equal to exponential e j pi by 3, j pi by 3. Okay, and at plus 4 e j pi by 3. Okay, as 2, okay, at k equal to 2, at k equal to 2, okay, is equal to j pi divided by 6. Okay, j pi divided by 6. Okay, and j pi divided by 6. Okay, give you here. Distribute them. Okay, this term non-zero, this term is non-zero for a minus 0, a minus 4, a 0, a plus 4, and a plus 4. Oh, sorry, a plus 2 and a plus 4. Okay, next one you can grouping them. This term, the first term and the fifth term. Okay, you grouping them to be, okay, try to find, okay, the you can find the trigon form of them and the power the second term and the fourth term, you grouping them, you can find the trigon form again. Two of them is already adding, ej theta plus ej minus theta, therefore it will be cost function. It's cost function. This term is a cost function, but I give the highlights, to give you, this 4 pi divided by 5, and this is pi divided by 6, and this, 8 pi divided by 5 and pi divided by 3, The next one is the continuous time periodic signals xt have the fundamental variance 3, The non-zero Fourier series coefficient xt are specific at ak, when equal to jk, when k is less than 3. It means is have only k is less than 3. It means you have only 0, ak 0, a0, a1, a2, only 3 terms, It means 0, minus 1, 1, minus 0, minus 2, 2, It's only 5 terms left, 5 terms left, And in this case, is t equal to 4. T not equal to 4, therefore omega equal to 2 pi divided by, omega equal to 2 pi divided by t naught, Omega equal to 2 pi divided by t naught, T naught equal to 4, therefore it equal to pi divided by 2. It have only 4 terms left, 5 terms left, at the 0, at 1 and minus 1, at 2 and minus 2. Sorry for this, is a little bit earlier. Yes, sorry. A0 plus 1 minus 1 plus 2 minus 2. The rest is a 0, Substitute them is so that it equal to, jk, depend on k, right? The first term, if k equal to 0, it equal to 0, k equal to 1, ak equal to, equal to j and minus j, and if it equal to 2, it's equal to plus 2j and minus 2j, This term can regroup again, The first term and the first term and the fifth term you can group together, group together to be trigon, And the second term and the fourth term you can group together to be here, Again, it will be in the form of this e plus j theta minus e minus j theta divided by, if it minus, you must divide by 2j, If it minus, try to divide by 2j, or if it's plus, it will be by divide by only 2. If it 2j is mean the form is already in the side, By the Euler relations, it will be side. This form is the same, e plus 2, E plus j theta minus e minus j theta divided by 2j, it will become side, Both of them is side. I show you so many exercise, So use so many exercise, Can I drink a little bit one, before we go to the next part. The next is the property of the continuous time Fourier series. The property of the continuous time Fourier series is about here. We will, I will provide, the table of the Fourier series, and the Fourier series pair to you, But you must know how to use them and when to use them, Read the instruction very, very carefully. If it order you to determine the Fourier series from the definition, you must integrate them from the Fourier series definition step by step. But if it order you to use the table or don't specify the method to use them, you can use the table and the property and so on. Okay, and this section will present the numerous property of the Fourier series. Okay, the Fourier series have the several property which make the Fourier series an extremely valuable mathematical tool in the study of the continuous time, the signal, and the system. It will be convenient to define the notations sorry. Okay, it will be convenient to define the notation similar to that used in the Fourier series to indicate the pair of the signal and its transform. Okay, the time domain is xt. The Fourier series of them is ak, or you can write them Fourier series of xt. Okay, or ak is here. Inverse Fourier series give you xt. Okay, therefore you can write xt and the Fourier series ak will be here. The Fourier series pair between them. Okay, xt and ak is a Fourier series pair. Okay. Okay, the property of them. Okay, the first one is a linearity. Okay, the linearity. Okay, the Fourier series. Okay, okay, the Fourier series of them. Okay, Fourier series of xt is give you ak. The Fourier series of yt give you bk. If you add between x and y, the Fourier series of them is okay adding between ak. Okay, adding ak and bk together. Okay, if a is x multiplied by a, capital A, you multiply capital A to ak. If b is multiplied by ak, is give you b is here. Okay, due to the due to the linearity properties. Okay, that is a readily extend to the linear combination of the arbitrary number of the signal. This property is very powerful when we apply the Fourier series to the complex signal. You can split the complex signal to be each term. For example, if the signal is very complicated, you can extract the signal to be even part and the odd part, or maybe split them in a symbols. Okay, 10 symbol signal. Okay, this signal can use in a very complex situation. For example, today in the real communication, the signal will be broadcast in a very wide band. Okay, the wide band signal is very complex. Okay, it's a nonlinear. It's difficult to solve. Therefore, instead we solve them in that manner. No, we cut them into a small piece, and we assume that each small piece of the signal is a linear band. Okay, a narrow band instead. And in the narrow band, each narrow band, you can determine the Fourier series of them. Okay, in the separate, independent from the other one. Okay, the first band, AK. Okay, the second band, okay, BK. Sorry, this BK. Okay, this thing BK. Okay, sorry. Okay, BK. If you have okay, another one is a ZT, is a C band, or so on. Okay. Okay. This technique is used in here. You can see that this graph is not the rectangle. Okay, it's not the rectangle. Therefore, in this case, okay, it's it's shift down by 1, okay, from the normal rectangle. Instead, you recompute them again. No, you maybe try to make them to be the classical rectangle. Okay, you shifting them is here. Okay, you can see that the original signal is a combined between, okay, the x1 is here. The normal rectangle is already in the classical graph, right? The classical rectangle, okay? And you can find them from the previous example, okay? And add, okay, you shift x1, okay, by use the time, the amplitude shifting by half, right? Shifting by half, okay? Therefore, the Fourier series of the first cloud, okay, the x1 is here, and the Fourier series of the second one is here, okay. Therefore, you add between two of them very easy, okay. Seem to be you split the signal to be, okay, this signal to be this, okay, and this signal comprised by x1 and x2. You determine the Fourier series of the x1 and x2. And in this case, x1 is easy. The Fourier series of the x1, okay, equal to ak equal to, okay, minus 0.5 by here. And for the, okay, x2 is here. The Fourier series, the rectangle, give you the sinc function. Okay, the Fourier series of the finally, okay, the Fourier series of the result equal to the sum of them. Okay. I think it's okay. My voice is not good. Okay. Okay, the table I give it to you, but to find them, okay, the way to use them, okay, you must, okay, know how to use them. The next one is the time shifting, okay. If you know the Fourier series of xt, okay, you would like to find the Fourier series of xt minus t naught is time shifting. No, you're not necessary to determine the ak again, integrate them, no. Okay, you only find them. Okay, you only find them, okay, ak, and you multiply by e minus j k omega naught t, okay, by here. Okay. Due to the time shifting properties of the Fourier series, okay, okay, the Fourier series magnitudes of the signal does not change. Okay, you can see that two of them is not change. Okay, e minus j omega naught t is here. It's not impact for the magnitudes. It impact only on the phase or the angle of them. Okay. Now, for the time shifting properties, the Fourier transform phase of the signals is changed. Okay. Okay, yeah. Okay. 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 Can I break 2 minutes? Okay. Only 2 minutes. Okay. We came back. Sorry. It's I drink some medicine. Okay. To take the cold. Okay. Next, okay. Can you hear me?
Yes,
ครับอาจารย์
Okay. Sorry, I guess a little bit cold. Okay. 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 Drink some medicine to reduce. Okay, to reduce about the pain of the cause. Okay. Using okay this property for time shifting. Okay. You can see that if you already known about the Fourier series of the classical fund. Okay. Here you can see that this graph is already you can compute from the previous step, right? From the previous example. Instead, you recompute them again. If you would like to determine the Fourier series of this graph, the top graph, you can see that the top graph is close similarly to the bottom one, right? You can compute them by reintegrate everything again, but no. If you know YT is here, you know the Fourier series of the bottom one, you not necessary to recompute them again. You only modify them a little bit, okay, by the Fourier series of the origin of the the Fourier series of the bottom one, you know them, okay, it equal to here, okay. You know you apply the Fourier, okay, the time shifting property. You shifting by, in this case, you shifting by here, right? T naught by here, okay. In this case, you shift by 1, okay, you shift by 1, okay, T naught equal to 1, okay. Therefore, BK, the Fourier series that you must compute, you only multiply them by here, the orange term is here, only that. The key of the property is mean if you know some Fourier series term already, okay, and if you would like to compute the Fourier series of the signal that have close similarly to the term that you have, okay, you maybe modify them, okay. You use the signal transform, time shifting, okay, amplitude scaling, or so on, okay, and you modify them, okay, and you adding them. Instead, you reintegrate them again. You can see that you only multiply by this term is very fast one, okay. Here, in this case, the frequency shifting, okay, if you shift AK by M, okay, you multiply by here, this term instead, okay, or conjugation, okay. The signal, okay, in general, XT is a real, but I told you that, okay, the case, in the general case, XT can be complex, okay. If XT is a complex, okay, what about that? XT is a real. If you know the Fourier series of A plus BJ, okay, A plus BJ. Here, you would like to find the Fourier series of A is conjugate, right? A minus BJ. Okay, it's the same, it's the AK, but you only take, okay, the Fourier series coefficient you flip, okay, of K. Substitute every K by minus, okay, and take the conjugation, okay, conjugate of them. Time reversal. For the time reversals, okay, is here. You know Fourier series of XT, okay, AK, Fourier series of XT equal to AK is okay. If the signal will be flipped in time, it will be flipped in the Fourier series coefficient too. Yeah. Time scaling. Okay. Time scaling is scaled by time. Okay. The Fourier series is don't change. You can see that the Fourier series don't change. Even though the Fourier series coefficient AK have not changed. Okay. The Fourier series representation have changed due to the change of the fundamental frequencies. Okay. You can see that AK is don't change directly, but it change indirectly, depend on the period of them. Okay. The periodic convolution, okay, this thing is very important, okay. Do you remember about the convolution? You convolve the signal in time, okay. The Fourier series of them, of the result of the convolution, equal to you multiply them, okay, and multiply by the period of them in the final step. But if you multiply the signal in time, okay, the Fourier series, you must convolve them, okay, you must convolve them, okay. Differentiation. Differentiation is here. If you differentiate them one time, okay, you know the Fourier series of XT, you would like to find the Fourier series of its differentiation, okay, the same AK, but you multiply AK by JK omega naught one time, okay. If you differentiate them two times, you multiply by JK omega naught square, all square, yeah. Now, you can use, okay, you maybe have the questions how to use this property. The property can use in this step, okay. In here, you can see that this graph if you do them directly, okay, this cloud, you must integrate them, okay, from -2 to 2, right? You model this cloud to be, okay, minus 2t, okay, minus 2t and plus 2t or so on, okay. But if you do them wiser than that, okay, you can see that, okay, you differentiate this cloud, okay, you differentiate this cloud, you find the slope of this cloud, right? This cloud will be 2 and 2, okay, and you find the Fourier series of them. The Fourier series of the rectangle seem more easier than the top one, right? The Fourier series of the rectangle, okay, you can determine from the previous step, okay, previous example. The previous example, okay, the rectangle may be shifted in the right hand a little bit by here, give you YT, give you this cloud, right? This cloud, okay? You only modify them. You know the Fourier series of the rectangle, okay? You only multiply them by, okay, by here, okay? Divide by JO, okay? Divide by JK pi, okay? Give you the Fourier series of this cloud, yeah? You can see that. Differentiate them one time, multiply by j omega t, okay, okay, and the last one, if you integrate them one time, divide by j omega naught, okay, the Fourier series divide by j omega naught. Conjugation symmetry, if xt is a real, okay, ak equal to a conjugation, okay, and reverse, okay, and so on. All property will give it to you, okay. You can see the details, okay, and how to use them in the example, okay. It's only review that. The key is that the property can facilitate your problem, but in the case that if you cannot find the Fourier series directly from the integration, or if you can find them, but it's very difficult one, okay, it can facilitate you. Okay, the possible. This formula is frequently used to determine the power spectrum of them, or the powers of the signal. Sometimes you cannot find them in the time domain, but you can find them in the Fourier series domain instead, okay? Take square of them and take sum of, okay, in one period, okay? It's here. From the possible relation equation, the left-hand side term of the equation is the average energies of the signal xt in one period, okay, in one period. From the possible relations equation, the average energies of the signal xt in one period may be determined by computing the energy in time domain xt squared, or computing the energy in the frequency domain, so called as the average power in the k harmonics component of the signal. Okay. The Fourier series, okay, property, I will give it to you. And the Fourier series pair, I will give it to you. Okay, don't worry about that. Okay, yeah. If you do, okay, if you must take the exam on site, okay. But if you must take the exam online, okay, will be told you later. Okay, maybe take the exam by the Microsoft Teams in there. Okay, I will be open the room. Okay, and will be instead I will show you the slide. I will show the question instead. Okay, and you submit that. Okay, to my email. Okay, I will show you. I will tell you later. Okay, if we must take the exam online, but now we don't know what about the situation is. Okay, maybe online or maybe on site. Okay, the university don't announce, don't tell me yet. Okay, any question?
No.
Okay, I think it's okay. If you don't have it, okay. Okay, I correct the attendance first. Okay, okay. Sorry for break a little bit due to during. Okay, I have the cold. Not fortunately that is not the COVID yet. Okay. Okay. For you, you must okay save your health things. Okay, because maybe another 1 week for maybe 10 days for the midterm. Okay. Good luck. Okay. See you next time. Okay. Next time is maybe after midterm, right? Oh, not yet. After next year. Okay. The fights. Okay. Right. See you again in the next year. Okay. Good luck. Dismiss.
Thank you,
Thank you,
อาจารย์
อาจารย์
See you ค่ะ
Thank you ค่ะอาจารย์
Happy New Year, everyone.
Same to you ค่ะ
Happy New Year
มีนิวเยียครับ
โชคดีนะทุกคน
รักษาสุขภาพค่ะอาจารย์
ค่ะ
Thank you, Ajahn.
Yeah, you're welcome.
Happy New Year, sir.
Happy New Year too.